Welcome to Beekeeping Today Podcast Shorts, your quick dive into the latest buzz in beekeeping.
In 20 minutes or less, we'll bring you one important story, keeping you informed and up to date.
No fluff, no fillers, just the news you need.
Brought to you by Betterbee, your partners in better beekeeping.
Hey everyone, welcome to this Beekeeping Today podcast short on Varroa treatments. This is a multi-part series covering the different treatment options available to combat this honeybee pest. Each short in the series will cover one specific treatment option. For the series, we've invited Dr. David Peck from Betterbee to join us. At the end, we'll collect all of our shorts, put them on the website, and make a ready resource available for our listeners to find the Varroa treatment that works best for them. So let's get on with this. Hey, Becky. Hey, David.
Hey.
This is so exciting. We're going to do a short episode, but I think to cover Varroa, we're going to have to probably do about 20 or 30 short episodes,
It'll be
right?
a lot of short episodes instead of one very, very long one.
Well, that's right. As with all of our Beekeeping Today podcast shorts, each episode is, 20 minutes or less. This will help listeners to learn about the treatment option that meets their beekeeping goals. This is the introduction episode, and we'll cover Varroa in general and why you need to control them. Future shorts will cover each treatment option by class, active ingredient, and or product name. Becky, David, this is a big topic, and it's going to be fun.
It better be.
Wait, was that a plug?
Yeah, was that a plug?
That's the only reference I'll make to my present employment. I think this is going to be a good opportunity for folks to really engage fully with what are Varroa mites, how do we kill Varroa mites, and longtime beekeepers are sick of thinking about Varroa, but there's always new miticide options. And so it is really valuable. I find that the more expertise a beekeeper gets in all of the different options available, the easier it becomes to figure out what they should do today to treat the mites that they've got in their hive today. And so I'm really excited for us to really create this table of contents, basically, for Varroa management options.
It'll also be handy because the Varroa impact on your colonies changes, and our tools to actually control Varroa change. So it'll be nice to have a format where we can maybe share any updates in the industry in this series.
Yeah, exactly.
Yeah. And I also think it's going to be fun or worthwhile for our listeners to be able to find the short that deals with the product they are using at a different specific time at the season. So if they pick up oxalic acid and they want to know how to use oxalic acid, they can pick up the episode on OAV and run with it. This will be a fun series to do.
I think we have to start at the beginning, though, and that's where Dr. David Peck, Varroa expert, is going to lead us through a quick background in Varroa. Can you do that quickly?
I can try. So what is a Varroa mite? They're parasitic mites. They feed on bees. They reproduce inside of the colony. They can only live on honeybees. They are inexorably bound to the colony in which they live. Essentially, every Varroa mite that most beekeepers see is a pregnant female mite. She is going to be crawling around on the outsides of the bees in what we call the phoretic phase or the dispersal phase, this period when they're riding around on the adult bees and feeding on the fat bodies, which are an important organ in the health and lives of our bees, that the Varroa mites are basically slurping right out through their bellies like they're drinking with a straw. Then they go into cells and they reproduce in those cells. They lay eggs. The female mite lays a series of eggs. The first one that she lays is always an unfertilized egg that hatches as a male. And then she lays a series of fertilized eggs that hatch as females. So they use the same system that honeybees use, even though they're not really at all related to them. So one unfertilized male egg, a series of fertilized female eggs, the mites all hatch out. Their mother is feeding on that pupating bee and feeding on the hemolymph, not the fat body, because of course that organ hasn't really formed in the developing bee yet. So they're feeding on the hemolymph there. The young mites are feeding on the hemolymph. They're all, commingling with each other as they reach sexual maturity. And then the male mite incestuously impregnates his sisters. All of them reach, complete maturity. The bee, weak but still alive, chews its way out of the cell, and then the mother mite, unless she's gotten to sort of the end of her story and she's keeled over, but typically the mother mite and all of her now mated daughters are going to ride out on that bee and jump onto another bee to get some more food. The male mite and any immature females are going to die down in the cell. And this happens in our colonies over and over and over again. When there's brood, the mites are taking that opportunity to reproduce. When there's no brood, the mites are going to be riding on the bees and happily nourishing themselves from the bees' own stored nutrients and waiting for that opportunity to rush into some brood cells and reproduce down there. So that's really the long and short of the life of a Varroa mite. They're a relatively new parasite as far as, the evolutionary history of our bees is concerned. They are a parasite originally of an Asian honeybee species, Apis cerana. But they jumped into our bees, the Western honeybee, Apis mellifera, probably only in the last 100 or so years, maybe even less than that. They've only been in North America. They've only been in the United States since 1987. So, we act like this is sort of old hat. It's, us beekeepers have been fighting Varroa forever, but the bees have really only been dealing with them for a short amount of time, and most of us have only been dealing with them a short amount of time. And so there's been this great effort to try to develop new and better tools to fight them. And that's what this series is really going to let us explore. What are the options that work? What are the options that don't? What, used to work but doesn't work anymore? What should you use in the summer? What should you use when it's hot? All of those are considerations that beekeepers need to make because we don't have a silver bullet. There's no magic product that if you just, figure out what to order from the catalog, you're going to be able to keep your mites under control and never think about them again. They do require attention and learning and management. And so we want to make sure beekeepers have all the tools they need to make good choices.
I wanted to just pick on one point that you made in terms of the life cycle is that everything really happens underneath the capped cell. And that's why when we're looking at the bees, if we're not seeing mites, the beekeepers tell you they're there, they're just under the capping. You can't tell just by looking.
And even more than that, when they're feeding on the bees, they are almost always in the exact same spot, which is on the underside of the bee's abdomen, wedged up in between the overlapping armored plates down there, typically skewed onto the left side of the bee, so that they've, that gives them the best possible access for their mouth parts to feed from the bees. But it means that even if you didn't have any brood and you were just staring at the bees, you're not going to notice any mites unless you're picking the bees up by their wings and flipping them over and looking at their bellies. And so, between being hidden in the brood and hidden underneath the bees, there is no worse way to monitor your mite population than pulling out a frame of brood and looking at the backs of your bees and saying, I don't see any mites, so I guess I don't have a problem.
Well, let's talk about that then, because we talked a little bit about the life cycle and the history of the Varroa. Why should we test? I think we touched on it, but let's talk a little bit about why test and what are the different testing options we have to reliably understand what's happening inside our hives in regards to Varroa.
Yeah. I mean, as a scientist, I think Becky thinks, I think any good science-minded beekeeper, so I'll speak for you too, Jeff. If you can know or have any sense of what your mite population is in your hive, it's better than not knowing, right? You can't make a good decision if you're just sort of shooting in the dark. That being said, there is a school of thought that says, I need to treat these bees multiple times per season just to keep the mites under control. So what's the value of testing? And so I think it's important to know, if you're not going to treat until you get to a certain mite threshold, then obviously you need to test so that you figure out when you get to that threshold. If you are going to treat regardless, it's still valuable to say, I'm going to treat because my mites, seem like they're sort of middling to low, but I don't want them to get any higher. That's going to be a different urgency in the bee yard than if you monitor and you find your mite levels are through the roof. So it's really valuable to have a sense of what's going on in the apiary, how urgently your bees need your attention. In terms of monitoring, obviously we've said looking at the backs of your bees is a really bad strategy. I've grabbed bees by their wings and flipped them over and looked in their bellies. That's also a pretty bad strategy because it takes an awful long time to get enough bees to figure out how many mites there are. So what most folks rely on is either the screened bottom board, or the IPM, the Integrated Pest Management Board. There's different names for it, which is just a screen that allows debris and detritus from the hive to fall down through it onto a monitoring sheet. And then, among those pieces of debris are dead Varroa mites or live Varroa mites, and you hope they'll stick to whatever's on your board. So then you can pull them out and count and say, all right, this board was in here for 2 days. This is how many mites fell over 2 days. And so I can figure out what the daily mite drop has been under that colony. And it's a nice test because it's a passive test. It's something that you can get just by monitoring, putting that sticky board under the hive and coming back a few days later. You can get maybe a ballpark for your mite population, but it is not a terribly precise method of figuring out how many mites there are per bee inside of your colony. And that's usually the measure that we need to rely upon. And so many people far prefer using, an active direct monitoring method, a sample-based method. And so in that, you need to collect a sample of a known number of bees and then separate the mites from those bees. And then you can figure out how many mites you've got per bee. So there's different methods that folks use to do that, but the principle is the same for all the sample-based methods. Take a sample of bees and then separate the mites from them so you can figure out how many mites per bee you've got. There's a few different methods that folks use. The powdered sugar shake involves using powdered sugar to separate the mites from the bees. The alcohol wash or the soapy water wash, those are also going to use those substances to separate the mites from the bees. The advantage of the powdered sugar shake is that the bees aren't immediately and directly killed by covering them in powdered sugar to get those mites, to fall off of them. That's not to say that those bees don't have a reduced lifespan. And some research tells us that it's a pretty substantially reduced lifespan. But we don't kill them immediately. The alcohol wash or the soapy water wash, those bees are pretty well dead as soon as you add that substance to the jar. But in all of those cases, if you do it right, you can get a sense of the number of mites per bee, which is going to help you estimate the overall mite population in your colony. It's always an estimate because you're not going underneath the caps, and we know that's where the action is. So it's still going to be a ballpark, but it winds up being a little more accurate to let me say, wow, my mite levels are really high, or, well, they're about what I'd expect for this time of year, or, hey, these bees are keeping their mites relatively low. Doesn't mean you're not necessarily going to treat, but at least gives you a chance to figure out what's going on in the hive before you start meddling with things.
And the standard for beekeepers is number of mites per 100, correct?
Yeah, it's typically reported as the percent infestation, number of mites per 100 bees, which is annoying because all of these sample-based methods typically involve taking a half cup of bees, which it comes out to being 300 bees. So we take a 300 bee sample, we figure out how many mites there are per 300 bees, and then we've got to divide it by 3 so that we can talk about our percentage infestation, or the mites per 100 bees.
A little bit of a math barrier there, but I bet beekeepers are up to it. I want to add one more reason to test. Actually, 2 more reasons. First, you need to test before and after a treatment to know that it worked. And that's really important. And the other thing, David, I think, and Jeff, the first time you test, you're not good at it. The second time you test, you're still not good at it. And testing it, once you lose that barrier of being afraid to test, being nervous to test, and then actually getting good at it, you're going to be better able to take care of your bees.
Yeah, absolutely. And that's particularly true for the powdered sugar shake. It's very tempting for people to say, well, I don't want to kill the bees, so I'll just put this powdered sugar on them. The methods for that to work well are pretty exacting. If it's a little bit rainy that day, if the bees have mouthfuls of nectar and they start regurgitating that, it can be a real mess. Yeah. So the alcohol wash or the soapy water wash, that's sort of a foolproof method. The powdered sugar shake is one that I would really only recommend to certain beekeepers who can really trust themselves to follow the recipe, as it were. But no matter what the method is, it's still just an estimate of the mite population.
David, when you're sampling the bees, do you collect them right off the frame? And from what frame are you collecting them from? Or do you shake them off into like a dishpan?
Yeah, so I personally prefer to shake the bees off the frame into a dishpan.
Yes.
But I have certainly used these cups and scraped the bees right off the frames. There's a lot of folks who do a lot of alcohol washes who far prefer that method. But I like shaking them into a pan or into a tray, scooping out my half cup of bees, and then working from there. Whatever method you're using to actually get them, into your container, you're always going to be sampling from the same standardized population, and that is the nurse bees on the brood combs of your colony. If the colony has brood, you want to be sampling from those nurse bees. Is that because the nurse bees have the most mites or the fewest mites compared to foragers or bees up in the nectar? Doesn't really matter. We're using a standardized measure, and the standardized measure is to sample from the brood nest. And so we need to get that. And it doesn't really matter if they've got the most mites or the fewest mites or an average number of mites. It's that when we're comparing our numbers to research or comparing our numbers to each other, we have to trust that all of my bees and all of your bees are coming from that same population, which is the bees that are wandering around on a brood comb.
And brood comb, is that open or closed cells?
I've heard it recommended that you sort of get a frame that has both, but you're more interested in actively fed open cells than you are in capped cells. So, if you have the choice between them, you don't want eggs because there's not many nurse bees there. There's not much to do. Capped brood are just being kept warm, but the standardized method is to draw them from a frame that includes open brood cells that are actively being tended by nurses.
And without going into deep details, just make sure when you collect them, you don't pick up your queen.
Absolutely.
I was going to say that.
It's happened not just to all of us.
Also, if you're collecting it from the frame, make sure you roll down with the cup instead of up, because one makes the bees mad and or makes them defensive, and the other is just a really easy collection method. So
yeah, absolutely.
And what levels are we looking to try to keep after we sort through the what comes off, the number of mites that come off the bees?
That's where it gets sort of hard, because over time, as we've learned more about Varroa, and also as some of the viruses that these mites transmit between our bees have gotten worse and worse, we've started to get less and less tolerant of having medium levels of mites in our hives. It used to be that you were told that you should treat whenever you had more than 5% infestation. And then that became 3%. And now the standard going wisdom is 2%. And I've talked to plenty of very successful commercial beekeepers who have great overwinter survival. And they think a part of that is that they treat whenever they get above 1% infestation. And so we continue to try to knock these mites down to lower and lower levels and to treat more and more often to keep the mite levels low. But it is difficult, because if I need to treat whenever I get to a tiny, tiny, minuscule number of mites in my hive, there's a chance that I might sample 300 bees and not find any mites and still prefer to go in and do that treatment. So the standard threshold that most people will suggest to others is that you treat when you get 2 or above 2% infestation. So that's 6 mites per 300 bees on a lot of these sample-based methods. For the screened bottom board, the number I typically hear thrown around is that when you get to 10 or more mites falling per day, that might be a colony in need of treatment. But all of these are very open to interpretation. And so it's important to remember that we need to address these mites whenever they get to dangerous levels, and that many beekeepers find that addressing the mites before they get to a dangerous level in the hive actually leads to better health outcomes. Because if I let the mites become a catastrophe and then I kill all of the mites, all the viruses that they were just transmitting between all of my bees, those viruses don't just magically go away.
Right.
And so now my bees have gotten sick, even if I kill the mites. So, when you're sampling, there are thresholds that we use to guide whether or not it's time to do a treatment. But often we find that we sample our mite levels, we learn what the current mite levels seem to be, and then many times we'll still do the treatment that we had intended to do at that time of year, but we're going to do it far better informed about whether the mite level is acceptable or slightly problematic or extremely problematic.
This is fantastic, and we're getting a great understanding of why Varroa are bad, how they impact us, and how we can test for them. In our upcoming series on Varroa treatments, what do we have to look forward to really quick?
Well, you can kind of divide mite interventions into two camps. You've got chemical controls that you can use, and then you've got non-chemical controls and techniques and methods. So the chemical controls are going to be all of the different legal registered products that are approved for use in beehives, and each of them has their own pros and cons and caveats, and we'll go through each and all of those. The non-chemical side of it, you can talk about different techniques and methods that you might use. You can also talk about using mite-resistant bees. That's one strategy to help to reduce the pressure of these parasites on your bees. No one chemical control and no one non-chemical method or bee breeding program seems to be enough to solve the Varroa problem for beekeepers and their bees. And so we're going to talk about all of these different tools in the toolkit because you're often going to be using more than one tool for the job. Each season, you might be trying to combine a non-chemical method and bees that have been bred for mite resistance with 2 or 3 different miticides that you'll apply at the right time throughout the year. And so we want to make sure beekeepers are well equipped to navigate these and to talk about them and to understand why you would or wouldn't try one or the other of those methods, at a particular time of year.
David, thank you so much. Jeff and I really appreciate all your wisdom and how you shared it extremely clearly for our listeners. And we can't wait to start with our first treatment in the next episode.
I'm looking forward to it.